surd is a number being applied to a square root function which does not give us an integer. And what I mean by this is, if we look on the left hand side here, we have numbers being square rooted and they give integer numbers, integers being whole numbers. They give root 25 is going to give us 5, root 9 is going to give us 3, root 144 is going to give us 12, these whole numbers. Now, surds appear when we apply numbers to a square root and cannot get a whole number. We cannot get an integer. So the likes of root 8, root 5, root 3. This is where we cannot simply break down this square root into a whole number. So that is what a surd is. And a surd can be left in this form. So you see our root 8, these cannot be simplified anymore. Our root 8, our root 5, and our root 3. So let's look at some calculations that we do when dealing with surds. So we have two surds, root A and root B. A general form for root A times by root B will be root A times B. So what we do, we open up a big square root function and apply a multiplication between the two numbers in either square root. So in this case, root 3 times by root 5 will be root 3 times by root 5 under one square root function. Therefore, the whole surd will be root 15, and that is a surd because it cannot be simplified anymore. And if you put this into your calculator, you'll end up with a decimal, so we cannot write it as an integer. Looking at the second question, we now need to deal with our whole numbers and our surds independently. Therefore, we do 2 times 4 first as our whole numbers, and then we deal with our surds second. So root 3 times by root 5 again, we get root 15, and obviously 2 times by 4 is equal to 8, and therefore we put together our two numbers to get our final surd to be 8 root 15. Okay, now looking at root 2 plus root 3 squared. Now this is going to use your knowledge of algebra. So we write this out as root 2 plus root 3 as two brackets like this. This is what the squared function means in this case. Therefore, we're going to use our FOIL method, which entails saying timesing the first numbers of each bracket. So the first numbers of the first bracket times by the first number in the second bracket. Then we're going to look at our outside terms. So this will be this term and this term. Then our inside will be root 3 and root 2 in the middle, if we were to look at our two brackets as one big sandwich. Then our last term, so the last term in our first bracket times by the last term in our second bracket. So if we were to conduct our FOIL method, we're going to get our first term to be root 2 times by root 2. And this is another rule that we've come across. So when we have two functions, two surds more like, which are equal to each other and they are timesing together, notice that they simplify to the number within the square root. Therefore, root 2 times by root 2 will simplify to just 2. Now, we are told to do outside terms. This is going to be root 2 times by root 3. So, root 2 times by root 3. If we look at our above general rule, this is going to be root 6, because 2 times 3 is 6. Therefore, we're going to have add root 6. Then looking at our inside terms, we're going to get the same thing. So root 3 times by root 2, and we're going to get root 6 here. Then our last terms are going to be root 3 times by root 3, which is going to be positive 3 from our rule of root a times by root a. So now we can collect like terms. And you may be wondering, how do we deal with two surds like this? So we treat each of these surds, because they're exactly the same, they are a function of root 6. So we can add them together to get two lots of root 6. We do not add the surds inside each other to get root 12. We'd more look at it as functions. So we look at it as like an x variable or a y variable. And when we collect like terms, we notice that there's two lots of root 6's. So that's how we put them together. Then dealing with the numbers, it's pretty standard. So our final answer is 5 plus 2 root 6. Okay, now looking at simplifying surds, we need to work backwards from what we just learned. We notice that a times b is given by root a times by root b. And this is what we learned here, but just in the reverse order. So to simplify these surds, we need to break down our root 50 into two square root functions, and we want one of them to be a square number. And what I mean by a square number is something which can simplify to a integer. And this is going to be our 1, 4, 9, 16, 25, etc. So a square number is something which will, when applied to a square root function, will give us an integer. Now looking at root 50, what is a factor of root 50 that you can see is a square number? Obviously, we're going to break this down into root 25. And to get from root 25 to root 50, we need to times by root 2. Therefore, that is our breakdown of root 50. Now, looking at root 25, we know it simplifies to 5. So we can put this, we can then further break this down into 5 times by root 2. Now, our last step is to just write this as 5 root 2. Now looking at root 48, we now need to break this down into two surds, with one of them being a square number. In this case, we can break it down into root 16 and root 3. Now, breaking this down, this will lead us to 4 times by root 3, which gives us 4 root 3 as our final answer. Okay, now dividing surds, it's very similar to our multiplication rule. Our root a over root b can then be written as the root of a over b. And this is our general formula for dividing surds. So in this case, we're going to get root 36 over root 3 is going to be equal to the square root of 36 over 3, which in this case is going to be root 12. Now, looking at a slightly harder version of this, we're going to see 15 root 24 over 3 root 3. The way you can attempt this question is to isolate the numbers and the surds. So we can write this as 15 over 3 times root 24 times by root 3. And now we can break down this into two separate fractions. And we can put 15 over 3 times by root 24 over root 3. Then simplifying this down, 15 over 3 gives us 5. And from our above formula, we know that root 24 over root 3 is just the square root of 24 over 3, which is then 5 times by root 8, leaving the final answer to be 5 root 8 like that. Okay, now looking at adding surds, we mentioned this previously, but we need to collect like terms. So we need to count how many lots of each surd there is, how many of the surds appear. So as you can see, there's 1 root 3 here and 2 root 3 here. Therefore, the simple version of this is 2 lots of root 3. Looking at this, we have 5 lots of root 3 plus 8 lots of root 3. Therefore, we have 13 lots of root 3. Looking at subtracting surds, we have 2 lots of root 7, and there's no coefficient of root 7 here, which makes this 1. So 2 minus 1 is going to give us 1 lot of root 7. Similarly, in question 2, we have 11 root 3, so 11 lots of root 3 minus 6 lots of root 3. We have this equal to 5 lots of root 3. Okay, that's going to conclude today's video on calculations with surds. As always, please make sure to like, comment, and subscribe, and I'll catch you guys in the next video. Peace.